Tata. Okay. Hello everyone. I think everybody is able to hear me, both people online and people here. Okay. So if you guys are not able to hear me, please let me know. Okay. So myself, Vimal from Graphisoft. So I'm Customer Success Manager here in Singapore. So today we are going to see Graphisoft's AI Visualiser. And together with that, we will see other AI tools that we have developed locally and also some of the AI works that our Graphisoft team is working on as a research project. Okay, so let's see the background of AI in AEC industry and then go into the AEC's our artificial intelligence visualizer that we have developed, and it is available for users to try out on their ArchiCAD in ArchiCAD 27. Okay, so we all know we are in industry 4.0 where smart technologies are taking a big leap. So we all know like digitalization is slower in AEC industry, and similarly we also have the smart technologies that is being used in AEC is much slower. But to take advantage of this, we can use it at least in the design stage more compared to the construction stage. And we are going to see some of the tools and technologies that could be used in the design stage of construction life cycle today in this presentation. Okay, so here you can see some of the potential areas for AI usage is design optimization. We can do some scheduling, automated scheduling, documentation like creating dimensions inside your BIM models, and then some safety and construction project monitoring can be done using the AI technologies as well. Okay. So artificial intelligence is the whole concept where we can make the system perform specific tasks which is required by human intelligence, but it can be performed using AI automatically. And machine learning itself is a subset of AI where we can have a structured data. Say for example, we can classify the data and then let the machine learn from it and then perform certain specific tasks. While deep learning is something where we don't have any classified data, but over time the machine will be able to learn the processes and tasks that is being performed by human, and it will learn from it and then it will perform those tasks automatically or by itself. So that is what is deep learning, and some examples could be like translation and all that could be done using deep learning. Okay, so here are some practical examples of machine learning and deep learning. Like for machine learning, we have Facebook news feed. So based on what people normally see or what people normally are interested in, it will give the feed based on the users' interest inside their Facebook account. So similarly for deep learning, we can have like language recognition and also the translations of languages, which is normally quite tedious when it is done by human, and also the image classification. Okay, so let us see some of the AIC applications in the artificial intelligence applications in AIC industry so far as some tools. So we have tools like denoising. So denoising done by NVDIA is actually rendering image or rendering. Sorry. Okay, so it's actually a rendering tool.
Do you record from Zoom? Record from Zoom.
Okay. Okay, so can participants please mute yourself? Okay, so all right. So there are other tools like GenMap MEP for Revit add-on, and also some Project IQ for Autodesk BIM 360 as well. So similarly, we have also come up with our own tools inside Graphisoft ecosystem, and it is available for the customers to use as well. So which we are going to see it today. So here are some of the AI tools or technologies that could be used in the architectural field. So ArchiCAD is more focused on architecture, though we are having people using ArchiCAD for structural and MEP. We are focusing on that as well, but there are a lot of architects who are using ArchiCAD. So here's the focus. So these could be some of the technologies that could be used in the architectural domain itself. So let us see one by one of them. So AI can be used for model checkers. So if we have BIM models, we can perform collision detection, we can check for best practices, we can check for local legislations, and then we can come out with those results for the checks based on the model that we have, and also the best practices that is being performed in the model checking. So the MEP routing tool can be automated using this AI. So we can create custom connections based on AI. So it can suggest the users when they create a new connection, it can suggest the type of connection that could be more appropriate for the design. And then we can reduce a lot of time using this MEP routing AI artificial intelligence tools. And then 3D model optimization. So a lot of time human resources are required to optimize the 3D model in terms of material usage and so on, and also the inconsistencies in terms of like overlapping elements or duplicate elements and so on. So AI could be a good solution to check the model and then give the results based on this optimization, and which will reduce a lot of time in the design stage. And then we also have this design optimization for layouts. So based on the requirements, the user can give some inputs, and based on those inputs, the AI can generate the layout for rooms for your building model. And then we can choose based on, like, we can have multiple iterations, and based on those iterations we can choose the most optimized one for our usage. And we can also perform certain tasks of documentation using the AI. So say for example, arranging the layouts inside the sheets can be done using AI. So it can give multiple suggestions based on which we can choose the best optimized solution to arrange the drawings, views inside the sheets before we publish them into PDF or DWG or so on. Okay. And we can also have dimensioning tools. So AI can dimension the elements. So we can use it for classification, as I told earlier. So once it is classified, it can identify the element type, and based on those element types, it will be able to dimension on the floor plan or on the elevation, or even in 3D automatically using this technology. Okay. And aside using it in the design, Graphisoft also uses AI in content generation for our Graphisoft Learn portal. So AI translator modules are used to develop local content. So once we have the content in English, so if you want to serve the wider market around the world, we are using it to translate that content into the local languages. And then after that, we are also using AI for voice cloning. So we can generate voice over for these videos using the voice of our trainers who doesn't even know that language. So it has been done in Graphisoft already, and it has been used in our Learn portal for localizing the content for different zones. So here are some of the innovations and research that Graphisoft is working on, and mainly we are working on AI assisted design. So you can see it on our roadmap, public roadmap, which is currently under research. Will be using AI and machine learning for automating certain tasks like design optimization, sustainability, documentation, and so on. So here is the main topic for today, which is the AI Visualiser, which is available from ArchiCAD 27 in ArchiCAD. So let us see what it is and how it can be used. So AI Visualiser is actually not a rendering tool. We are not calling it as a rendering tool because it uses the 2D image, and then based on that 2D image it creates a visual. Okay, and it is powered by stable diffusion, and whatever model that you are having inside ArchiCAD, it takes a picture of that view, and then that view is created as a very nice image which can be used for various purposes, for communicating with clients and so on. and the image and model that you have inside ArchiCAD is stored within ArchiCAD and your local machine, and it's not going inside any cloud or anywhere. So it is done within your local machine itself, and the engine for AI Visualiser is staying within your machine as well. So you need to have a bit more higher end machine for this application to run. Okay, and here are some of the installation guide. Sorry, I think I need to change this. Just give me a moment. So this is the user guide, this is the system requirements, and this is the installation guide. The first one is the installation guide, the second one is system requirements. Okay, so if you guys want to check out, please scan the QR code and you will be able to check out the installation guide, system requirements, and user guide as well. Okay, so here is the user interface of our AI Visualiser. So you will have a preview of the image that you have generated, and then there are some inputs that is required by the users to input. Okay, so you can use your creativity to prompt the AI Visualiser to generate some content for you in terms of images, and then it could be inspired by any of the designs that you have previously done, and this visualization is done during the concept design stage. So you just create some boxes using our morph tool, and then those images could be those views can be used to create some visualization like this. So we are actually not creating any of these models here, we are just having some boxes, and from that it generates a very nice image for you to communicate with your clients and so on. Okay, so here is the workflow. So just generate some boxes with your conceptual, which is your conceptual model, and put some text prompt there, and also some user inputs are required, and after that you will be able to generate an image, and if you want to generate it multiple times, you can generate, and it will give you a redefined image, and you can save the image every time. Okay. Sorry. So the installation and then the system requirements are earlier shared. So as I told earlier, you need to have a bit more high-end RAM and VRAM devices. And if you have any questions, you can go to our ArchiCAD Graphisoft community, where you can post your questions, and people around the world using AI Visualizer will be able to communicate with you and then help you develop your content. Sorry. So as you can see here, we have a view inside ArchiCAD which has just your conceptual design, and based on your conceptual design, the AI Visualizer will develop your an image which has more content added to it using the AI Visualizer add-on. So for that, you just need to give this prompt which says a modern house, a city in the background. So as I was telling earlier, so AI Visualizer just uses your 2D view. So it just takes a picture of your ArchiCAD view and then generates this image for you. So let us see this in action. So I have my ArchiCAD 3D view open, and you can see here I've created some shapes here using the morph tool. Go to Windows and then Palette. You will see the AI Visualizer there. Okay, so here is the user interface, and you can see here we have prompt window here where I can just type in anything. So I'm typing a house design in the rural background, and then we have other inputs. So let me just generate this now. Let us talk about the other inputs a little later. So once I generate, you can see the AI Visualizer takes an image of the 3D view that I have in the background, and then it starts generating. And you can see the AI engine that is generating my image from the ArchiCAD that is running on the background. So you can see the progress here. So based on the inputs that you give, the progress will be much faster or slower. It depends on what input that you give. Say for example, if you give the shape fidelity, the image size, the number of iterations and everything to be higher, then the time taken for generating the image will be higher as well. So you can see here right now 60% is done. So yeah, so it's 100% done. So here you can see the image. So you can see here, this is the view that I have, and then I generated this image, and this is just a morph, and I didn't do any modeling. Okay, so based on the prompt that I gave, I was able to generate, and if I want to save the result, I can save the result as well. So the result is saved as a PNG. And if you are creating the view, right, say for example, in this particular view that I have just created, you can see here, I've just created some shapes here, say similar to door, windows, and so on. And the same thing can be seen on my 3D view. So if at all you want to make this shapes visible, just choose an appropriate 3D view in which all the shapes are visible, and then try to run, so that the AI visualizer will be able to use that on the image, and then it will generate a content for you. Okay, so if you are not happy with this content, you can regenerate as well, and you can just click generate here, which will start regenerating for you. Okay, and then some basic tips and tricks for this AI visualizer to be used is always try to use this uh, this format of your prompt. So try to use a visual style. Say for example, if you want to have a realistic pencil drawing or a realistic image, and then the architectural style, so it can be a modern architect or contemporary design or whatever, so you can just put the architectural style there. And then the building type, whether it is a house or office building or a high-rise building or so on, and then specify the materials following that, and then the environment. So environment could be like a city or a rural background or a mountain background, and so on. Okay, so try to follow this prompt if at all, so that it will give you the best results. So you can see here the same view has been used to create two different images. One is the prompt is just a modern house, a city in the background, and the other one is the realistic pencil drawing of a modern office building with metal surfaces, a city in the background. So you can see here the same view, but two different images based on the prompt that we have given. Okay. And then the next is shape fidelity. So the shape fidelity is something to just stick to the same shape or to change the shape in your design. So there is a slider here inside the UI. So if you keep it as 0, it will not really stick to the shape that you have used inside your 3D view. But if you have the shape fidelity to 100%, it will stick exactly to the same shape that you have used inside ArchiCAD, and then it will generate a content out of it. Okay, so you can see here is another example of how a content can be generated. Okay, let me go back. So here you can see here the shape fidelity. So if I make the shape fidelity to 0 and then just generate, let me just wait for the results. Okay, so you can see here I've changed the shape fidelity to 0, and you can see it's totally changing the shape of my design. So it is not really the same as what I have drawn inside ArchiCAD. So if you want to stick to 100% shape fidelity, you try to use this slider, and then try to change the shape fidelity for your results. Okay. So the next is the image size. So you can see here the image size, you can choose from the drop down here whatever size of image that you want to use. But if you choose a higher pixelate images, it will take longer to generate the image. So if you choose a lower one, it will be much faster. But if you choose a higher pixel image, it will take a bit more time to generate the image for you. Okay. So probably maybe I will just try to use a higher end one, and then see how long it does it take. And it not just changes the resolution, but also the quality and then the precision of the result is affected using this parameter. So that is the reason why it takes longer. If you're using a high pixelated high resolution image, it will take longer to generate the result because it is highly precise, and the quality is also much improved compared to the lower one. Okay, so while it is generating, probably I will go to the next slide. So here is the number of iterations that you can perform. So by default, inside this AI visualizer, we have 20 iterations as minimum and the maximum as 50. So you can choose between this using this slider and then perform the number of iterations to get a better result. Okay, so as you have more iterations, you have more details and then precision, but it will take a longer time to generate the result for you. Okay, so the next one is the slider for the prompt strength. So this slider will let you to decide how much the prompt has to be stick to when you are typing something on the prompt, right? So how much should the AI visualizer stick to that prompt? You can choose from here. So at the minimum, you can choose a 25%, or if you want, you can choose it to be 100% as well for the prompt strength. So if you want to decide what exactly you want inside the result, you should give a very good prompt, and then you should make it 100% as well, so that the result is as expected. Okay, so we also have option for lock result. Actually, when you are generating, right, so when you generate the first image, if you're okay with the look and feel of that image that you have generated, so if you want to lock the look and feel of the same into the next result, you can just use this lock result. Okay, so the same look and feel will be generated in the following result as well. Okay, so the other changes will be like depending on your shape fidelity, the prompt strength, and so on, the result will change, but just the look and feel will be the same. Okay, so it takes longer to generate my image because I choose a higher resolution image. I think we will wait for a few more minutes for this generation to get over. No, at the moment we cannot. So we cannot use our own background to generate the image. So we have to write it as a prompt, which background that you want to use to generate the image. Probably that could be one of the features that could be added in the future, but at the moment we cannot do it. Yeah. The look and feel also using the prompt. So you can choose using the prompt. So there is one option called lock result. Maybe I'll try to show. So you can see here there is an option called lock result. So you just give the prompt, and then if you're happy with the look and feel of that result that you have generated, you can just lock result and then click generate for the second time, so that the same look and feel will be carried over to the next generation as well. But the look and feel, basically you decide it based on your prompt. So if you want to have a winter with snow and all that, you have to give it in the prompt. The data is stored within your machine. So this AI engine is running within your system. It's not a cloud-based engine or anything. So it's running within your engine, and that's why it requires a high RAM machine for you to run this AI generated image. So you can see here, even for my machine, it is not very good for this. So that's why I turn off this option called start in high VRAM mode. So I've turned off that because I'm just using a laptop. It's not really a very high-end machine. So I turned off this feature. So there is a bit of optimization. If you want to have, you can turn on this and then just make it even more realistic. Yeah, it is recommended to use desktop. Yeah. Meanwhile, if you guys have any questions, maybe we can discuss. So I see there are a few questions. So understand AI visualization is powered by Stable Diffuse. So no, there is no extra tokens to be charged to the user. So you have ArchiCAD 27 subscription or forward user, then you will have AI Visualiser. You can use it. Already released officially. Yeah, AI Visualiser is already released officially. So it is already released officially. So you will be able, if you have ArchiCAD 27 installed on your machine, you will be able to use the AI Visualizer. So you just have to go and download the engine and then install it based on the installation guide, and then you will have the AI Visualizer for your usage. Okay, so you can see here, so I changed the resolution and I have a different image totally. So for my case, I haven't chosen what kind of an image. Say for example, if it's a sketch or realistic image, so it automatically takes based on automatically takes by itself. So if I key in here what exactly I want, then I'll be able to get the results accurately. So in that sense, I would say my prompt is not that strong. So I just give a house design in a rural background, so I'm able to get this result. Okay, so as I was telling earlier, so there are options for you under the advanced parameters where you can choose the number of iterations. So by default it is 20, and if you want to make it 50 to have more precision and then the quality, you can choose 50 from here. And regarding the prompt strength, the lowest is the 25, and then if you want to make it 100% to stick to the prompt 100%, then you can choose 100% from there. So normally people want to just have exactly what they represent here in the prompt, right? So in that case, just have it as 100% by default. And then here is the AI engine address. So it's actually, as I told earlier, it is on the local machine itself. So you can see the local the address there, the IP address for your AI engine. So it is within your machine actually. And once after you open the AI visualizer, right, so you have to click this start AI engine, and then only you'll be able to click generate. So I've done that earlier. So when you start the AI engine, it takes a few minutes for you to let you to generate the images. But for my case, since I've started it earlier, I was able to just click generate here. Okay. So if you want to stop the AI engine, you can stop, or you can just refresh it from here. Okay. So let me go back to the presentation. So as I was talking about the log result, so you can see here inside the AI visualizer the result. So you can have log result. So I can just log result and then click generate. So probably I'll just reduce the image size so that it generates faster, and then just click generate here. Okay, so let me just go back to the presentation until it generates the results. So here are some of the tips for you guys. So if you are using AI visualizer, right, so try to choose a view which is more appropriate. So as I was telling earlier, so what the AI visualizer sees is just the 2D image of your view. So it is not really checking the shapes or how the geometry is. So if you choose something from the top and then generate an image, you will get something like this. So but if you choose a image or view like this, you will get a proper result. So what the AI sees, it really matters, and then try to use an appropriate view which shows all the shapes that you have defined inside. So as I was telling in the previous example, so I was creating these geometry here with all the opening shapes and everything, right? So this has to be visible so that this will be visible on your result as well. So try to choose this view. Say for example, if I choose something like this, right, so I don't really see the shapes I've defined, so that the AI visualizer will give a result that is more appropriate. So try to use this kind of a view and then click generate so that it will give you a proper result. Okay, and then if you have created a complex geometry, try to show those complex geometry in the view itself. So if you are not showing those complex geometries, then it will not be shown in the result. Okay. And then I was earlier telling about the prompt itself, right? So the prompt matters. So as yes, you can see here, if you use the word house in your design, you get this result. But if you're using office building for the same view, then you get this result. So when you're defining your prompt, try to be more precise so that you let the AI understand what exactly you want. And even if it is like a high-rise building or something, so you need to mention that it's a high-rise building so that it understands the scale of your model and based on that it will generate the result for yourself. Okay, so maybe I will just use this. You can see here I've just created a simple shape here, and then let me just use the AI Visualizer to generate a high-rise building from here. Okay, so I'm giving a shape fidelity of 100%, and then I'm going to generate the result. So as I was telling earlier, the order of your prompt actually matters, but it is not very critical. But though, if you want to have a very precise result that you are expecting, then it is better to follow the prompt in an order that I was showing earlier. So let us wait for it to generate the results. Meanwhile, if you guys have any questions, please feel free to ask. Yeah. This is actually not a library. So I've just used morph tool, and then I've created some random shapes here. Yeah. Yeah. Images. No. At the moment, no. No, it's not really ArchiCAD 27. It's part of the engine itself. So this engine is able to generate, this kind of images based on the machine learning that they have already fed into those engine. Yeah. It's not on the cloud. Yeah, it's on the system. Yeah. Yeah, I will be showing that. Yeah. 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 You can actually use, but it will give you some results which might not be exactly same as what you are rendering. So this is not same as rendering. Rendering is different tool. So rendering just gives what exactly you have modeled inside ArchiCAD and what material you have used there. But here it will generate based on what you have given in the prompt, and then it keeps changing every time as well. So this cannot be replaced for a renderer. So that's why we need not name this as AI renderer. We just call it as AI visualizer because it keeps changing every time based on the prompt and also on the number of iterations that you choose. Okay, so here you can see there are some materials that they have used in the geometry itself, and that geometry without any specific prompt is able to understand the material. Actually, this AI engine will be able to understand the material that I've used in the geometry, and then it is using the same without any specific prompt. But if in case you have not created such prompt, that such surfaces or materials inside your model, then you can just use the prompt to create the same result or a similar result. Okay. So this is the same as what I was telling earlier. The order of the words do matter, but it's not very critical. Sorry. So here, I think this is more appropriate. So first choose the drawing style, and then the scale of the building, the architectural, whether it is modern office building, and then the material used, and then the environment. So this is more appropriate. But even if you change, right, it doesn't change drastically, but it's advised to use this kind of prompting. You can also use negative prompting. Say for example, if you don't want to see something on your result, right, you can use negative prompting. Say for example, in this case, they have used not a winter scene or no snow, so that you will not see that in your result. So negative prompt also works, so you can be more creative using using those negative prompts on your prompt. Sorry. And here are some of the styles that you can use. This is the default style, or pencil drawing, or anime style. You can use any of these styles for your result. Sorry. All right. There is one function called loopback function. So when you have generated some result and you want to use that result as an image for the further generation, right, for the next result, you can just click shift and then click generate. So that what it does is it will just use this image that you have generated for the first time, and then based on that result it will create a new visual. So when you don't click shift, it will just create a new image based on the geometry that you have inside ArchiCAD, and then it will be completely new. But when you click shift and then generate, it will just use this image that you have generated, and based on that it will just add more features to it and then give you the result. So this is not exactly same as lock result. Lock result is just locking the look and feel of your image. But when you click shift, which is the loop back, it will just use that image as a result, and then based on that result it will give you a new image. Okay, so let me wait for the results to generate. Yeah, you can see here it was using the previous image that was generated, and from that image it is trying to change the background and then some inputs there, and then it's giving me the other result. So here is another example of it. So this was the first image that was generated, which is a realistic pencil drawing. And then based on that it is able to give a modern house, which is realistic. All right, so far any questions on this AI visualizer? So we are going to the next topic of Solibri model checker. So I can see some questions here. Yep. So based on the prompt that you give, it can consider the scale. Say for example, if you are having a high-rise building or an office building, you can just add it on the prompt itself. So it will be able to consider the scale or the size of your building. And then in terms of massing, right, if you want to add, like some shapes around your building, you can just create it as shapes as well, so that that will also be considered in your result. If I feed the AI visualizer a very detailed 3D model in ArchiCAD, will it slow down the processing speed? Yeah, it will slow down the processing speed, and then you might not be really getting the exact rendering of your model. It will just generate a similar one with some added features to it. So AI visualizer cannot be replaced for an AI renderer or just ArchiCAD renderer, so that you will have more details into it, and those details will, like make the visualization or the result generation slower. Will the AI visualizer be able to recognize the materials already assigned in the ArchiCAD to generate the new images? Yes, it will. So if you are able to add those surfaces to your model, it will be able to recognize those materials, and based on that, it will give you the result. So probably you can use this loop back function to have more control. So you can give a detailed prompt actually. So if you want to control the result, you can give a very detailed prompt. So you can add as many details as you want, and based on that, it will give you the result. So that is how you can have more control at the moment. And also the shape fidelity. So if you want to stick to the exact shape, try to have it as 100%, so that the shape is not distorted or something on your result. So I have one more building here. Maybe probably we can try to create results out of it. So I'm going to use realistic pencil sketch of a modern house with the city in the background. Let me just click generate. Meanwhile, if you guys have any questions, feel free to ask. Any questions here? Uh, no, no. Oh, I'll change the view now, just now. I just changed the view and then yeah, yeah. Yeah, only when I click generate, this image will come, the exact background will change, yeah. Maybe one tip here is to refresh the engine if in case you guys are, like finding something weird results. So you can just click the refresh engine and then do the generation, so that you will have a better result. Yeah, history will be gone. Yeah, so the engine will be started newly, and then it takes a few seconds or few minutes to restart the engine for you, um, before you can click generate here. Okay, so you can see the image here. So it takes the shape as given, and it gives me the results as per the prompt that I've given. So here I've given a pencil sketch, so it gives a result like that. Any other questions? I haven't tried that. Probably we can try. I haven't tried that. Maybe, yeah. We can try that later. Yeah. Any other questions? Okay, so here is the new image. Probably I use this high-rise building and then I put modern high-rise building uh, with okay, I just put with Singapore as background. Let's see how it turns out to be. Sorry. Architects, so they can generate multiple iterations of their design intent, and then they can use this to communicate with their clients to convince them with the design at the early stage. Yeah, so they need not spend time on creating all these models. So they just create the shapes, and based on that shapes, they will be able to generate the. This is very new, so I am not sure if anybody else is using it in Singapore at the moment, but we are just trying to promote it so that people can start to use this. Yeah. Yeah. Probably I can show that now. So just search for Graphisoft community, and then you can just go to our community page, and under the building together you have challenges and AI Visualiser challenge. So you can go through how to participate in this challenge, and then you can submit your entries here. So there are a few entries that have been posted earlier. Okay, so you can see from here some entries. Okay, so here are some results. So based on this prompt, this geometry, they are able to generate this result here. And here are some high-rise buildings. So you can also participate in this sorry, challenge, and then you can win some exciting prizes as well if you are interested. Okay, I don't think we can use the prompt as Singapore background and then get some results. So it just gives me some, like plantation around. So, okay. So I'm just trying with Marina Bay Sands in the background. Let's see if we are able to get some result. Okay, I don't have, yeah. So we cannot be as specific as, like giving the exact uh, location or the place where you want to have this uh, project to be. Yeah. Okay. Uh, any questions about this AI visualizer before I move on to the next topic? Okay. So if no questions, maybe I will move on to the next topic, which is machine learning for model checking. So I guess most of you have heard about Solibri, which is Graphisoft's sister brand under the Namascheck. So Solibri is used for model checking, and then it's a very good coordination tool to federate all the models from multiple disciplines and then do an automated model checking based on the rules that we have defined. So we can parameterize the checking inside the rules, and then based on those it will check and give you the results. So those results can be created as presentations, which can be exported as BCF file, which is BIM collaboration format, and this can be communicated with people or the project stakeholders who are responsible for those issues to fix them. But within Solibri we will be able to use the Solibri API, and then the Solibri API can incorporate the AI models inside the Solibri rules, so that you will get results based on those machine learning from the previous data that we have. Okay, so how we can generate? So we are going to show a very simple model generation tool which is developed by the University of Waikato, New Zealand. So this is available for free for anyone. So if you have some data that you want to use it to create your machine learning model based on any of the algorithms that they have inside this module, you will be able to generate that model, which is actually a model that can be used inside your API. And then you can generate results based on those model you have generated. Okay, so let us see how to do that. So the user interface of Vika is quite simple. So you just have to open the Vika GUI, and then it will prompt you to choose the file. So this file is actually your data. So you can just use any text editor tool, and then you can create your data. So it should be in a specific format. So if you use their guide, it will let you know how to save your data as a specific format. So here you can see I've already saved my train data, which is the training data. So you can see you can edit it using a notepad or any text editor. And for this particular rule, we are going to check the minimum width of the corridor, and then if the corridor minimum width is not meeting the criteria, say for example if the minimum width is supposed to be like 2 meters, and say for example if it is like 1.95 or 96 mm, say for example if it is acceptable, but Solibri doesn't know whether it is acceptable or not, even if it is 1 mm lesser. So in that case we can use some previous data where, say for example, if the authorities have accepted if it is just 3 mm lesser than what it is required. So in that case, if they have accepted that design, and then we can choose, we can enter the minimum width and also the tolerance, and also whether it is accepted or not. So if it is accepted, it is true. If it is not accepted, it is false. So we can enter that as a training data inside this text editor, and then you can save it, which can be used inside your model to create your machine learning model for your rule. Okay, so here you can see I'm choosing the training data that I've just created, and then you can see all the different parameters that I have inside the training data. So one is the minimum width, the other one is the tolerance, and then the third one is the class, which is basically classification, whether to accept or not to accept. Okay, so I have 48 instances of my train data. So if you have more instances, then you have more accurate results as well. And for each of these attributes, we have the statistics of it, like the minimum, maximum, mean, and then the standard deviation, and then it is shown as a graph here as well. Okay, so the first step is basically to choose the data that you have, and then once after you have choose that data, the next step is to choose the algorithm that you want to use, or basically the machine learning model that you want to generate. So there are models like supervised models and unsupervised models. So you can choose anything from there and then just use it for your model. Okay, so here the next step is to classify the machine learning model or machine learning algorithm that you want to use. So you can choose here the linear regression, the Gaussian processes, the logistic. So these are some of the models that are already available in machine learning. So based on the data that you have, you can choose the appropriate one from here. So for this user interface is quite simple, that even for people who really don't understand um, the machine learning concepts, right, they will be able to use this user interface to just generate some model uh, based on the algorithm that they can choose from the result. So here you can see you can use the training set to generate the output. So you can see I've used the 48 training sets, and based on that we have generated the report. So you can see here 100% of my results are classified, so my data is actually clean. So if your data is not clean, say for example, if any of your instances are not having any classification whether to accept or not to accept, you will be able to see them here. So for my case, the instances that I've used inside the text editor file where I've edited those, so it's having a result either classified as true or false. Okay, so you can see here 16 of them are classified as false and 32 of them are classified as true. So if you want to have a test set supplied, so you can use that also. So we have trained data and we have test set data. So you can see here for this I don't have the result, so the classification I don't have. So whether you want to accept or not to accept, I can just put a question mark there, so it will give me a result whether to accept or not based on these two test sets. So I can choose the test set from here and then choose the trained data, test set data. Okay, so here we want to classify, we can use the class parameter and then we want to get the result, so I use the class parameter as the result, and then here I can choose output predictions as plain text, and then I can click start. So you can see here my first test is false and then the second one is also false. So based on the training data that I have input, I'm getting this results as false for both of my test set. Okay, so you can see here you can save your model. Once after you have generated your model, you can just simply save inside your machine, and then this model could be used inside Solibri. So for people who maybe who do not know about Solibri API, Solibri has API functionality where you can develop your own rule from scratch using the Solibri Java API. So if you are familiar with Java coding language, you will be able to generate your own rule in Solibri, which can be tested against those criteria that you have set inside the rule. So here in Singapore, we have used Solibri API for developing the test rule set for the LTA ADC requirements 3.1. So we have developed around 70 rules for LTA model checking. So based on the criteria that they have inside ADC 3.1, which is architectural design criteria 3.1 of LTA. So inside those Solibri API, we can also use this model that we generated using Vika, and then we can develop some rule sets from scratch. So which I can show now. So you can see here is the development environment where we normally generate the rule or create the rule using the Java API. So inside here I can use the result that I have I've created from the Vika, and then I can use that to give the minimum width tolerance and then the true or false, and then based on this I will be able to get the results out. So here I'm using some dependency. So for people who understand development, so we can use the dependency. Basically I'm using the libraries of Vika so that it can be used inside my code to do the checking. So basically this is a classification example where I'm just classifying the result whether it is acceptable or not acceptable based on the trained data that we have given. So this is an example of classification in machine learning. Okay, so here you can see I'm classifying the instance, and then based on that it will give me the result. Okay, so I'm starting Solibri. So here I'm using the Solibri building, which is a default model available after you install Solibri inside your machine. So you can use the rule set manager to define your rule set, and if you want to see your machine learning rule that we just generated, you just create a new rule set, and then you can just drag and drop the newly created rule. So you can see it from here. So I'm using this check for corridor width, and then I'm just dragging and dropping it inside, and this okay, there are two rules. One is check without the machine learning, and the other one is with machine learning inside. Okay, so the rule parameters will have the user inputs where you can define what exactly you need to check. So here you can see I'm choosing the space, so I want to check the width of the corridors. Okay, so I'm just filtering out only those that are named as corridors, and then the minimum width required is 1.5 mm. Okay, so this is the one with the machine learning model incorporated inside the rule, and then I'm just classifying the corridor to be checked, and then here I'm entering the same parameter. So both the rule looks same, but the results might differ. Okay, so when I click check model, so you can see one rule is giving an error which is having issue there, the other one is okay. Okay, so the other one is okay because based on the trained data it is acceptable to have this particular result. So you can see here my width of the corridor is 1.475. So the same rule, if without the machine learning it is failed, but it is acceptable with the machine learning concept inside, because based on the trained data, if it is just 0.25 meter lesser, it is acceptable. Okay, so this is how machine learning can be used for Solibri rule checking as well. So if in case you guys want to use Solibri on your projects, do let us know. We can help you to implement such machine learning concepts as well for your projects. Any questions on this? Yeah, it will. Yeah, it will. So it depends on the accuracy that you set.
Basically, what Vimal is showing is for each person, zero percent. He allows some of the results by, but we can override the checking method based on that, the same data is created. So in the future, without intervention of human, we can decide for you based on the past. So these are ultimate things that I have as an idea.
Yeah.
Rely on the model itself.
Mm.
So the modeling technique, for example, like to the wall and
Yeah. So yeah, I think the geometry is very much important when you're doing measurements, especially when you're doing the checking. So when you are exporting your IFC model from the authoring tool itself, right? Um, so you can do a pre-check inside Solibri whether there are right, the model elements are used to create the model. Yeah, check for standards. So if that is not proper, then we need not even go to this stage. So even in that stage, you know that the model is not perfect for the checking. So there are some pre-checks available. And also if you want to include the base quantities from your model authoring tool, you can include those base quantities for export, and based on those base quantities, you can do the check as well in Solibri. Say for example, if you have a beam and the column junction, right? So if you use the base quantities, so the BIM authoring tool itself will create the quantities. Say for example, if you are relying on a volume, so if there is a connection there, so the volume generated by your BIM authoring tool is more accurate than the uh, volume that is being generated based on your IFC file. So in that case, you can use the base quantities to do the check inside Solibri as well. So it's basically like you can choose whatever that you want, uh, that you are already having in your IFC model to do the checking. Any other question?
the thing I can add is sometimes people use black so that happens in many tools, right? So people use that. All right. But when it comes to ArchiCAD also, there is a classification. So if you use classification, you don't use black on the wall. If you classify that as a wall, because I see it comes as a wall, that it will fix that as a wall. Right? So there is certain way of handling it. So based on as a coordinator of the person, you see the model and you have to do the classification. And sometimes you cannot give it to the modeler 100% for the standard. You can implement standards, but sometimes you get any kind of model. That's always when it comes to solid, it's always a learning point.
Thank you, Chidam. Any other questions? Have you guys used Solibri before, like in any of your projects? No, is it? Okay. Maybe if you guys want to see a demo of Solibri, I can just do. Yeah. Is it okay? You can check any requirements actually. So it depends on how you define the rule set, um, with respect to the parameters. So maybe one example I can give is the same rule can be used to check different things. Say for example, okay, I have distance between, yeah, component distance, yeah. So let me just create a new component result here. So I'm just creating a new rule set. So I have used this component distance rule inside that, and then if I want to use it inside my model, so I'm just starting a new model, and then let me just use this component distance rule. Okay, so if you go to the rule parameter, so right now you can see I'm using this particular rule, which is component distance rule, and the UI of each rule differs actually based on what you can check. So here you can see horizontal distance between the footprint of the elements. So if I choose the source component and then the target component, I can choose to find out the horizontal distance, and then whether the allowed maximum distance is 1 meter, or I can choose to check the required minimum distance. Okay, and then here if I change the criteria that I want to check shortest distance between spaces, so you can see it just between shapes, it just checks the shortest distance between the shapes. And then facing within distance, so you can see it checks for faces within distances, and directly above, directly below, horizontally alongside, above, within, offset. So same rule can be parameterized to check for different things. Say for example, if the services are at a certain distance from the column, you can use this rule. And you can also check how far is your the door from your stairs. So these kind of things you can check as well with the same rule. It can be defined to check different things using the same rule. Okay, so let me just close this. Maybe I'll just explain the user interface. So here we have we call it as layouts in Solibri. So we have file layout, model layout, checking layout, communication layout, information takeoff layout, and so on. So inside the model, so I can choose whichever model I want. So here I'm choosing the Solibri office building. Okay, so here I can give a short name. Maybe I just give A, and then if I want to add further models, right, so I can just right click. You can add multiple models inside Solibri. So here so here I'm choosing the ventilation model, and then probably I choose the discipline as ventilation here, and then give a short name as V, and then just click OK. So right now both the models are inside here in this 3D view, but if I want to just see the ventilation model, right, I can just add it to the selection basket, and then you can see I just see only the ventilation model. Okay, so if I add both of them together by selecting everything to the ventilation the selection basket, I can see everything. But if I go inside here, you can see the ventilation model is there. So if I select any of the element right now, I can see the spaces as well. So if you can see here, I'm selecting this duct here, which is which is colliding with the suspended ceiling there. Okay, so as soon as I select that, you can see this duct is coming from my ventilation model. I can see the V there, and if I go to the checking, so here you can see I can check architectural checking or BIM coordination checking. So these are some of the predefined rules. Based on these rules, you can customize the checks that you want to perform. So for example, we have created a rule for LTA ADC checking. So the rule set inside this ADC checking will be considering those that are required for ADC requirements only. Okay, so similarly you can create your own rule for maybe for checking the architectural components, or for MEP components, or structural components, and so on. So let me just use architectural checking, and then just click next, and then from here you can choose the rule set that you want to check. So here I want to include the MEP models and architectural models because I've added the ventilation model to this check as well. So let me just click OK. So I want to run my checks based on this rule sets that are predefined, and then just click OK. So let me just close this and then check the model. So you can see here, as soon as I check the model, I get the results, and the results are classified based on the severity of the checks that you perform. And there are some rules that are okay as well. So okay meaning there are no issue with that particular check. So distance between components, so here we are checking the distance between columns and MEP elements, there is no issue. Distance between doors and MEP elements, there are no issue. But if you expand the results here, okay, so here clearance in front of windows, so you can see here this particular rule is checking for clearance. So this rule 226, you can see the tag number 226 here, and then it's checking for all windows, and then it checks for clearance in front of those windows. Okay, so you can customize this to check the different things actually, even for doors. So if I just change this to door here, it will just check all my doors. So a same result, the same rule will be used to check the clearance in front of doors. Okay, so now let us check out the results. So you can see here, as I can go here and then check the result. So this particular window is having a column in front and it is obstructing, so that's why I'm getting the result here. Okay, so you can see here there are results coming out. So similarly, clearance in front of doors, I'm getting the same. So you can see here this particular door is hitting this water closet. Okay, so this kind of checks is very tedious for human to perform and find out this kind of issues. But with Solibri, we also have Solibri auto run, which means that you can select the rule sets that you want to check against your model, and then you can let it run during night time, and then tomorrow morning when you come, you will be able to see this kind of results, so that you can just review the results. And then once you review the results, right, you will be able to create issues out of it. So you can see here, I'm just creating an issue out of this particular result, and you can see there are some descriptions automatically added, and also the image has been added, and then the components has been added as well. So the distribution element, which is the water closet, and then the door is added to the BCF, and then here you can choose, you can assign it to someone. You can see whether the Archi is responsible for this, or you can see, you can choose whether MEP is responsible for this, or you can add a new tag as well. So if you want to let people add the tags and labels, you can add, and then if you want to reject it or accept it, you can reject and accept as well. So now I've created this issue, right? The next step is to go to the communications tab, and then where I can just create BCF file out of the results that I have checked. So you can see it automatically adds the issue that I've created, and this issue can be exported as BCF file. So you can see I can just click report, and then I can choose Excel, PDF, or BCF. So if I choose BCF, right, so they can import it inside the model authoring tool, and they will be able to see this particular view with these two elements selected, and then they will be able to resolve the issue very easily. But if you want to go with PDF export, maybe I just show you how to export as PDF. Okay, so you can see here it generates the report for me, and it adds all the information that I've added with the image, so that for people who are going with the traditional workflow of using Excel or PDF to report issues, they can use this as well. But the more digitalized workflow will be using the BCF file format. Okay, and you can also use information takeoff tab, where you can quantify or schedule the elements from your model. Okay, so let me just use this one, and then let me choose building elements and then takeoff. Okay, so you can see here it is quantified based on what I want to see inside the model. So the volume of columns, external doors, floor slabs, everything has been quantified, and we have a color representation. So if I want to just see only this load bearing walls, so you can see these are the only load bearing walls, and it is represented by color coding, and this can be exported as Excel report as well. So you can define the template in which you want to export, and then it can be exported in that template format so that it can be used for your project stakeholder to communicate with your project stakeholders.
Again, you show the machine learning part.
Yeah.
So it can be used only with the tool sets, or it can be used for
Technically, it can be used for quantity takeoffs as well, because we can generate quantity takeoff using API. So if technically it can be used with the quantity takeoffs as well. Yeah. Say for example, if there are clashes and you don't want to consider those clashes in the volume generation or in terms of quantity takeoff, you can neglect those as well. We can try that. Yeah.
everyone about the same. So these are the tool sets. So you guys are interested in business and how you want to actually get.
Yeah.
Is there any software, offer for trial?
There is 30-day trial. 30 days.
30 days. What do you get?
Best practices. Yeah. There are courses on LinkedIn as well if they are taking up a Solibri trial license. So there are some default rule sets available which I was just using, and there are some default models that comes along with Solibri. They can make use of those and then learn how to use Solibri, like how to customize the rules. Say for example, if they want to instead of checking the width of corridor, if they want to check the room size, how to customize the same rule. The same rule can be used to check for different things, right? So yeah. 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 So if they want to implement it on their projects, maybe they can reach out to us. We can help them with training, and also we can if they are interested in learning API as well, we can provide such trainings. Yeah. I think as a BIM user, it's not very difficult to use Solibri. Maybe probably it will take a month to master it. Yeah. I mean, not. I mean, yeah. Solibri probably just one day. Yeah. One day training is enough. Yeah, as I was telling earlier, there is something called auto run as well. So you can just schedule the Solibri to just automate the checks by itself so that it runs overnight, and the next day morning you just go and check the results and then review whether it is okay or not.
Imagine you create some time in your models area and can actually populate the model with the photo. And you can set up all the percent, all the checks, and all the so like they you get anyway. So you can show that they were
Yeah.
so it's like whatever you generate in AI is already verified. You get a very
And there are also BCF connectors. So if you generate BCF from here, right, you can just connect to the any CDEs and then you can just export the. Oh, yeah. Yeah. Yeah, yeah, no, yeah.
No questions, I think, can engage them separately and no.
Yeah. Okay. Thank you, everyone. Thank you. Thank you. Bye.
Yeah, outside already. Those online, they want to turn on the camera, so they already try to do. They have to try to take some pictures. Actually, got many times. Anytime maybe, yeah.
Sorry?
Your experience, what I think for the week.
I think with API you can try to make everything work, yeah, because with LTA, right, there were some checks which we were not able to use default rules. Say, for example, if there is an escalator, we want to check just above the pitch line of the escalator, we want to check if there is any hindrance, but there is no rule that is by default available to do the two such checks. So, yeah, we developed API to do such checks. We developed 70 rules, yeah, to check the 100% of ADC 3.1 appointments.
You can name card. I have a name card myself. Oh, yeah. I'm not sure if my phone can do that. I don't think my phone can do that. It's too old. Are you on LinkedIn? Yeah, look for on LinkedIn. Yeah, that's Thank you.